Hello everyone, welcome to Miss Lee's class. Today we're going to learn how to estimate square root. So today's objective, develop strategies for estimating a square root. Okay, I want you to look at the warm-up question. Find the length of the side of each square. Okay everyone, so we learned how to find the area of a square. So say we have a square like this and say the length is 5 and 5 centimeter. How do you find the area inside? So we can just multiply 5 and 5, which is 25 square centimeter. Is that right? And what if just the area is given? If the area is 25 square centimeter, so we can just simply take square root of it, square root of 25, square root of 25, and we can just say, oh, the side length is 5 centimeter. 5 centimeter. Is that right, everyone? Okay, look at this. We have a square with the area of 9 square centimeter. Then what's the side length? So simply take square root of it. Square root of 9 is 3 centimeter. Is that right? Again, square root of 9 is 3 centimeter. So the side length of this square is 3 centimeter. And this is a little bit bigger. 11 square centimeter. So everyone, we know 9 square centimeter. A square with 9 square centimeter has 3 centimeter side length. And we know a square with the area of 16 centimeter has, what's the side length? So square root of 16, so 4 centimeter and 4 centimeter. So we know 9 has a 3 centimeter, 9 square centimeter has 3 centimeter side length, and 16 square centimeter has 4 centimeter side length. But what about 11? So this is greater than 9 and less than 16. So that means the side length, we don't know what the side length is. The side length should be greater than 3 centimeter and less than 4 centimeter. Is that right, everyone? Okay, 11 square centimeter. The side length is, we can just simply say, the side length is, you can just simply take square root of it, square root of 11. The side length is square root of 11. And we want to know roughly how many centimeter this is. Okay, everyone. Then is 11 closer to 9 or closer to 16? It is closer to 9. Is that right? So square root of 11 is a 3 point something, but it's closer to 3. I think this is about 3.3 centimeter. All right? So this is how you estimate non-perfect square number, square root of a non-perfect square number. And you can use this method for other numbers. For example, square root of 1. What's square root of 1, everyone? It's 1. And what's square root of 4? That is 2. And what's square root of 9? That is 3. And what's square root of 16? That is 4. And we say square root of 2 and square root of 3 is 1 point something, 1 point something. And square root of 2 is closer to, a little bit more closer to 1. And square root of 3 is a little bit more closer to 2. So if you just guess it, so square root of 2 is roughly 1.4. And square root of 3 is roughly 1.7. So this should be a little bit closer to 2, and this should be a little bit closer to 1. So you can just check this using your calculator. All right? Okay, next, square root of 8. So do you think this is closer to 4, square root of 4, or closer to square root of 9? This is definitely closer to square root of 9, which is 3. So I think this is roughly 2.8. All right. Okay, square root of 13. This one. So this is about in the middle, but a little bit closer to 16. So the difference between 16 and 13 is 3, and the difference between 9 and 13 is 4. So roughly in the middle, but a little bit closer to 16. So I would say this is about 3.6. Okay. All right. Let's move on. Example 1. Felicity wants to know if a wading pool will fit in a small space in her yard. She must estimate the side lengths of the square wading pool, which has an area of 18 square meters. So when you have this kind of question, it's always good to draw a picture. All right, so let's draw a picture. And the area is 18 square meter. And we have to find the side length. Obviously, the side length is square root of 18. Is that right? And we're going to estimate this number. In between what two numbers should we place square root of 18? So we're going to find two numbers, two perfect square numbers. Okay? So what's the smaller number, smaller perfect square? So that is square root of 16. Is that right? What is the larger perfect square number? That is square root of 25. And square root of 16 is 4, and square root of 25 is 5. And square root of 18, that is 4 point something. And everyone, square root of 18, is that closer to 16 or 25? That's closer to 16, closer to 4. Is that right? So we say, well, it's roughly about, I think this is roughly about 4.2. Okay, use a calculator to approximate the side lengths of the pole to the nearest whole number. So 4.2, compare your estimate in part 8. So with the calculator's approximate answer. Okay, so let's do it together. Square root of 18. 4.2. So when you round it to the nearest whole number, that is 4. So the answer is 4 meters. Alright, so let's move on to example 2. So we have square root of 96. So which whole number is square root of 96 closer to? In between what two perfect square numbers should we place square root of 96? So let's find the smaller number first. What is the smaller perfect square? I'm gonna say that's square root of 81. What's the larger perfect square number? That is 100. So 96 is in between 81, square root of 81, and square root of 100. Okay, so this is 9, and this is 10, and square root of 96 should be 9 point something. But everyone, square root of 96, is it closer to 100 or closer to 81? It's closer to 100. And I think it's about like when you estimated, when you guess it, I think it's about like 9.7. Okay, so we can just say which whole number is square root of 96 closer to. So the answer is 10. And this is the justification. Okay? Alright, let's move on. Example 3. A square garden has area of 139 square meter. So what are the approximate dimension of the garden to the nearest whole number? So we want to find the side lengths. And of course, the side length is, you can just take square root of it. Square root of 139. And let's find the closest whole number, everyone. So to do that, like we did before, you have to find the smaller perfect square and the larger perfect square. So I want you to pause the video and try this question by yourself. Find the smaller perfect square and larger perfect square. Alright? Okay, have you guys just tried that? Let's do it together. What's the smaller perfect square, everyone? I'm gonna say it's 121, which is 11 square. And the larger perfect square is 144, which is 12. Okay, square root of 144 is 12, and square root of 121 is 11. Okay, so 139 is closer to 12 or closer to 11. So if you subtract 144 minus 135, that's only 5. And 139 minus 121, that's 18. So 139 is closer to square root of 144, which is 12. So we say the answer is 12. And net wire fencing is needed to keep out coyotes. About how much fencing would be needed around the garden? So we know the side length is 12, about 12. And we want to know the perimeter of this. Okay? How would you find the perimeter? You can just simply multiply one number. So you can just simply multiply 4. Then 48 meters. That is the perimeter of this garden. Make sense, everyone? Okay. Let's move on. Discussion questions. Which type of a number has an exact square root? So exact square root means when you have square root of 4. What is this? So you have an exact number, right? Square root of 9. What is this? You have an exact number 3, but square root of 5. So this is about 2 point something, but root 5 is closer to root 4. So it's I'm gonna say it's not an exact number. It's about 2.2. So this is not very accurate. This is just a estimate. Okay? So exact square root. To become an exact square root, the number should be perfect square number. Alright, everyone? Okay, so you write perfect square numbers. Okay, number 2. Which type of a number has an approximate square root? So you say non-perfect square numbers. Okay, everyone, that is it for today. Now you guys may start doing your homework. Thanks for watching, everyone. Bye-bye.